Right, this is example 6 on page 104. So we're still working with what you were using last lesson. There's basically two smooth vertical walls, smooth horizontal surface intersecting at an angle of 60 degrees. The smooth sphere, so we're not worrying about friction, is projected across the surface with speed 1 metre per second, angle of 20 degrees towards the intersection of the walls. Coefficient of restitution between the sphere and both walls is 0.4, and we want the speed and direction after the first and the second collision. So first collision, U parallel is equal to 1 cos 20. We're not going to get nice answers out from cos 20. U perpendicular is 0.4 sine 20. And U parallel is equal to U cos theta. And U perpendicular is U sine theta. So from there we can do 2 divided by 1 and that gives you tan theta is equal to 0.4 tan 20. Sorry, that's it to be 20. And so theta is equal to 8.2834 degrees. It's just a lot of decimals. I would always write them down to more than 3 sig fig, or use, do use your answer buttons in your calculators as well. And then U is equal to the square root of cos squared 20 plus 0.4 sine 20 squared. And U comes out as being 0.9496 meters per second. So we're expecting the speed to slow down a bit, which it's had, and the angle to be less than 20, which it is. So you can do a couple of rough checks on that. Second collision, I would do a second diagram. And so coming in there, we've got walls at 60 degrees. It's actually coming in at a really shallow angle, but it's not going to make a very nice diagram. So I'm going to just sort of accentuate that a little bit. So we're coming up to meet this wall this way. That's 0.9496, 8.2834 degrees, and then it's going to bounce off down this way so that this angle is a little bit smaller than this one here. And I can call that V, and I'll call that angle in there alpha, like so. And then it's the same idea, but we need to really be able to get into this angle here. So because the angle in this triangle adds up to 180 and the angle on a straight line adds up to 180, this angle here is 68.2834, around there. And then you're home and dry, really. So we're working with V, and so we can work with the parallel to the ball. So we know that V cos alpha let's just call that V parallel, is equal to 0.9496 cos of 68.2834, which is equal to 0.3514. And then V perpendicular, which is V sine alpha, is equal to 0.4 times 0.9496 sine 68.2834. So that's just using restitution on the perpendicular, and that gives you 0.3529. So it should start to feel quite repetitive. They're not the most exciting questions, I admit. So dividing tan alpha is 0.3529 over 0.3514. That gives you alpha is equal to 45.1 degrees. And then V, the speed, is the square root of 0.3514 squared plus 0.3529 squared, which gives you 0.498. We certainly don't need more than 3 sig fig accuracy. So yeah, I would try and use answer buttons, but I do find sometimes when you're working with decimals, it's good to write them down to more sig fig than you need, and then if you need to reuse them, they're there. But just be aware that you don't get a rounding error embedded as you work through. And yeah, that's it for that one.